Hey everyone, this is Daniel for Rock the JVM, and you are watching another long-form tutorial on idiomatic error handling in Kotlin. In this third long-form tutorial on Kotlin error handling, we're going to use a more advanced type called Raise. Now for this video, I'm going to assume that you know the basic Kotlin, and because this is a more advanced tutorial, I will recommend that you watch the context receiver video that I made earlier on the channel. You also have a blog version of this article if you prefer reading, so whenever you need to refresh your memory, you can go back to this video or to the written form at the blog with the link in the description. The best way to make the most out of this video is to write code with me, which is why I'm going to write code on camera. All right, without further ado, I'm going to go back to my IntelliJ project where I have a little object here with a main method. And I wrote a bit of code so that we don't have to type it ourselves. You can copy this from the blog post as well. So for this tutorial, we're going to simulate the backend of a fictitious job board. So we're going to deal with jobs, companies, roles, salaries, and so on and so forth. We have some data classes and some value classes here as well. We have a fictitious jobs database, which is an in-memory map. We don't want to deal with databases and whatnot. We simply have a simple map with a bunch of jobs that we're going to use to simulate the search of a particular job applicant. We also have an error model because we're going to deal with typed errors in this article. So we have an interface called job error with a bunch of fictitious job errors, job not found, generic error, and so on and so forth. So you can set up this code in your own IntelliJ project by copying this from the blog post. Now, before I get started, I want to also tell you about POM.xml because for this video, we're going to use Kotlin version 1.9 and Arrow 1.2. In fact, the Raise type that we are going to deal with is only supported by Arrow Core 1.2 onwards. As before, you have the entire POM.xml at the end of the blog post if you want to copy that, if you want to set it up in your project. So if you want, you can pause the video to do that now. All right, so if you've set up your project, the next thing that I'm going to talk about is Raise. In fact, Raise is all that I'm going to talk about in this probably long video. So Raise is a nice little context in the error library that allows us to handle and deal with typed errors or checked exceptions in our code. Now, there is a debate in the JVM world, and not only about whether checked exceptions or unchecked exceptions make most sense. And Raise is a nice little context that will allow you to check exceptions if and when you want so that you can return plain values without bloating your code unnecessarily, for example, like Java does and forcing you to do try catches. So here's an example of how we would use Raise. I'm going to define an interface called jobs. This is going to be a little service that will allow us to find a job by ID, for example. So I'm going to define a function, find by ID, with an ID as a job ID, and this returns a job. Obviously, the job ID might not exist in the database, but I'm still forcing this function to return a job. So I have to somehow deal with potential errors, for example, with job not found. So I'm going to provide a context, and I'm going to have a raise that I need to import from Arrow Core, raise of type job error, which means that this find by ID can quote unquote throw any instance of job error. So let me show you how an implementation would look like. Let me define a class called live jobs, and this extends jobs. Now, obviously, I need to override this little find by ID with the context receiver, and I'm going to override that as a single expression. So I'm going to say jobs database on this ID, and if this exists, I'm going to return that. If it doesn't, I'm going to quote unquote throw an instance of job error. Now, how do you throw, with air quotes, an instance of job error? In the context of the Raise type, you have access to an extension function called Raise with a lower caps R. Raise, and you can only pass an argument of type job error. So I'm going to have, let's say, job not found with this ID. So a quick advantage of using the Raise type is that you can only quote unquote throw an instance of the type that you declared in the context. If you try to raise some other data type, so if I, for example, create a different class, I'm going to have a data class, let's say some error with a message as a string. So this will be a val. This does not belong to the job error hierarchy. If I raise some error with boom, the compiler will not compile your code because this is a type mismatch. You can only pass an instance of job error. So I'm going to get this back to job not found with my ID. So notice the type safety of the raise context. Now, this function needs to return a job, but it quote unquote throws a job not found. How on earth do you use something like this? Let's go to main and let's try to instantiate a live job. So I'm going to have val jobs as live jobs. I'm going to try to call this find by ID function. So val my job as find by ID. So jobs find by ID on job ID, let's say 1. Now notice that I cannot really simply call this find by ID function because I need to pass the context receiver. So I need to somehow say with some raise instance, and then I can only find by ID with the some raise instance. Now, it's quite hard for us to create a raise instance ourselves and consume it, which is why I'm going to use a special function in the raise package that's called fold. So I'm going to specify fold here, and I'm going to import that from the raise package because fold has lots of definitions and lots of packages. And the version of fold that I'm going to use has 3 arguments. One is the block that I want to execute, which is a 0 lambda, and here is where I'm going to place my code. And the block needs to return a value, which is why I'm going to cut the value definition out, and I'm simply going to return the find by ID. The block needs to be a 0 lambda that can use the context of a raise with a particular type, and the type inference will figure out what type that is. Then we have recover block. The recover block will be a 0 lambda, so let me add a comma here because otherwise the compiler is going to go crazy, and we're going to have an error of type job error because the compiler already figured out that the first block is in the context of a raise of this particular type, in the raise of job error. So which is why we have the error typed with the correct type. So in this second lambda, I'm going to use a when clause. So when error is of type job not found, I'm going to print line job with ID 1 not found. Else I'm going to print line some other error, and I'm going to interpolate the error inside. Okay, the third argument is a transformation because the fold function takes an expression that returns a value in the context of arrays and can transform that value with a function. So I'm going to have my transform function with a comma here. So transform as a lambda, job, or you can use it if you want. I'm going to print line job salary for job with ID 1 is, and I'm going to interpolate job.salary. And job is the argument to the transformation function. So this is how you would use an expression that can return a value in the context of arrays. So at the end of the world, when you want to evaluate an expression that uses the context of arrays, you would use a function like fold, which creates a raise context. It's called a default raise by arrow and consumes that context. The blog post has a lot of details of how this thing is implemented and so on and so forth. Now, there is another overload of fold, which has 4 arguments. One is called catch. And this catch is a lambda from a throwable. Throwable, which is of type throwable. And this needs to return the same type B as the transform function wants to return. In this case, it returns units, so I'm going to have a print line, a serious error occurred, and I'm going to have my throwable here. And I'm going to add a comma, because otherwise the compiler is going to yell at me. So fold, in its more complete version, has these 4 arguments. Now, if you don't specify a catch block, the original block that may throw a JVM throwable will simply bubble up to the call site. That's one thing. The second thing is that the catch block will never intercept some throwable types. For example, virtual machine error, or interruption exception, or very importantly, cancellation exception. For various reasons. Virtual machine error is something that's very critical to the JVM itself. Interruption exception, or interrupted, I think it's an interrupted exception. This is the original thread killing. So interrupted exception is caught by actual JVM threads, and cancellation exceptions are used for the normal functioning of Kotlin coroutines. So if you catch any one of these types, you'll affect the normal functioning of various JVM or Kotlin features. So let's run this particular code, and then let's refactor it, and let me give you an example of how the catch block would affect the folding function in Raise. So let me run this particular program. So let's wait for the Kotlin compiler to do its thing, because we wrote a bunch of code. All right, and the job salary for job ID with 1 is value 70,000. Okay, cool. Let me refactor this a little bit, and I'm going to create a little class called jobs service with a private val jobs, and I'm going to have a function, let's say print job salary with job ID, and this is going to be my fold function, and I'm not going to search for job ID 1, I'm going to search for job ID, and I'm going to inject this job ID here. So I'm not going to use the wrapper function again because we have the job ID already. So we have the job service with print job salary. Now, if you don't specify a catch block, or if you don't treat all throwables, you will bubble them up to the call site. Let me give an example of how that mechanism would work. So let me define a class called currency converter. This is an example that we used in other videos as well. I'm going to have a function, let's call this convert USD to euros. We live in Europe, so I'm going to have an amount double. Never use double for money, but I'm going to use that here. And I'm going to make this nullable because I would like to treat null values as well. And this returns another double as well. I'm going to say if amount is null or amount is less than 0.0, then I'm going to throw, let's say, illegal argument exception. Let's say amount must be positive, and else I'm going to return amount times 0.91. I think that's the currency exchange rate at the time of recording. So this is a simple function, convert USD to euros. Now, let me show you how you can use that, and the illegal argument exception will be thrown for a job ID that doesn't exist, for example. So let me make this example very clear and very isolated to the currency converter itself, and I'm going to wrap this convert USD to euros in the context of a raise job error, so that we can see that the illegal argument exception simply bubbles up. So I'm going to have a class, let's call this raise currency converter. I'm going to have a context with raise job error. I'm going to have my function convert USD to euros. And I'm going to have my raise currency converter wrapping of converter. So converter currency converter. And convert USD to euros amount double question mark. This returns a double. And I'm going to simply call this convert USD to euros amount on the original converter. So converter.convert USD to euros. And obviously I forgot the private val so that I can use that. So private val converter so that I can use that here. Cool. Let me use it in main. So I'm going to have a fold. You know how you use fold now. So the block is going to be converter. Going to create one, so val converter as raise currency converter with a currency converter wrapped inside. I'm going to have my converter dot convert USD to euros, and I'm going to say -100 or something like that. And let me add a recover block. So recover as error job error, and I'm going to simply print it out. So I'm going to say print job error found, and I'm going to inject error. And then I'm going to have my transform as salary in USD. So again, I'm going to have a double. I'm going to say print line salary in euros. I'm going to inject my salary inside because the salary was obtained by calling the convert to USD function. Okay, so let me run this to see what we got. And notice that the illegal argument exception simply was thrown just as it was, or it would have been, for any other Kotlin code. So we need to somehow raise this in either the context of a throwable so that we can quote unquote catch it, or to raise it in the context of a job error and provide the catch block here. So I'm going to have a catch as error of type throwable, and I'm going to print line something bad happened, and I'm going to inject error inside. And if I run this code now, we're going to see the illegal argument exception being caught and displayed properly. So something bad happened, illegal argument exception amount must be positive. So the situation naturally arises when you want to compose two functions that are specific to different Raise contexts, and you want to bring them up to the same Raise context. For example, this convert to USD to euros would normally be specified in the context of throwable, or simply be written as regular Kotlin code with throwing exceptions. If you want to catch them and you want to bring this throwable into the context that you want to work with, for example, job error for a fictitious job application, you would use something like catch. So catch takes a function, so it takes a lambda, that would simply pass the convert USD to euros here. And then the throwable that would normally be caught inside, so error of type throwable. And then you can convert this throwable into your own domain model. So in our case, we have negative salary, so I'm going to return a negative salary here. So negative salary. But not just the value itself, but I need to raise it in the context. So I need to use my domain-specific function, raise negative salary. So as we did before with raise, if you want to quote-unquote throw an error of your own type in the context of a raise, you need to use this function. All right. So in this case, our convert USD to euros is now fully in the context of raise job error because the throwable was caught and we're raising a negative salary instead. Now, obviously, the throwable clause is a little bit too comprehensive here because throwables can mean anything. So let me narrow it down to legal argument exception and just raise negative salary instead. So if I run my program again, we're going to see a different kind of message being printed, job error found error, because now we're in the recover block. We can cut out the catch block because we don't need it anymore and let the other throwables bubble up if necessary. And that is because the illegal argument exception was handled in the raise currency converter. All right, so as you can notice, this is the basic mechanics of raise. There are a bunch of functions that we can use to create and consume raise context. So another one is catch, the one that we've used. Another one is recover, which rely on fold. So the fold is the more general of them. Now, two big things that I want to talk about further. I want to tell you how you can convert raise E to other types. For example, either, option, and so on and so forth. And how you can combine raise values and errors. All right, big thing number one, how can you convert raise to other types like either and option? For example, either is another way that we can handle errors, and we have a dedicated video and article about this type specifically. And I'm going to show you how you can convert raises to eithers. Let's go to my job service, and I'm going to define another function. I'm going to say, for example, fun company with job ID, so get company for this particular job ID. And this is going to be an either that I need to import. On the left-hand side, we have the error type, the undesirable value, job error. And on the right-hand side, we have the desired value, which is company, both of which are types that we've defined in our model. Now, we can use the either. And this is a builder function that will create and consume a raise context and will turn the value that we'll return inside this block to an either. So for example, in this case, I can do jobs, find by ID, which is known to return a job, and then I'm going to simply say company there. So I'm going to have my job ID. So either is a function in the raise package. And this simply takes a function from a lambda that returns an A. but in the context of a raise. So the implementation of either creates and consumes a raise context. You can also convert backwards. I'm going to have a function, I'm going to call this company R with job ID, job ID. And this returns a company. And I'm going to say company with job ID. And if I want to turn this into a regular company in the context of a raise, so context raise job error, I can call bind on it. And this bind is an extension function on an either that will convert that to a regular value in the context of the error type. So you can convert back and forth between an either and a regular value in the context of a raise. I'm going to give another example with options. So let's create another example, not for company, but for example, if I want to return a salary. So I'm going to have an option of salary if we have a job ID. So I'm going to have a salary, job ID, and this is going to return an option of salary. Okay, now I'm going to import option in arrow core, and the construct is very similar. We can use an option builder. So I'm going to say option, and I'm going to have my jobs find by ID, job ID dot salary. Now, in this case, we have a problem because the find by ID function is in the context of a raise job error. Now, the job error type is much too large for the raise necessary for options because options simply ignore whatever errors you have and just return either some or none. So the extra condition that you need to satisfy for the option builder is that the block must be in the context of what is called an option raise, which is a raise none, not raise of your particular type. So I'm going to wrap this find by ID thing into another function in the context of raise none. So I'm going to sketch this real quick. So I'm going to have a context, and I'm going to have a raise none. And none is the subtype of option. I'm going to have my find job by ID option. I'm going to have job ID, and this returns a job. Now, as a matter of fact, this should stay in the live jobs implementation. And I'm going to have jobs database on the ID. If not, raise none. Now, I also need to specify this in the interface as well. All right, and with the override modifier. And I need to now use it find by ID opt, and the code will compile. So the option builder has this extra requirement that the context must be a option raise. A very similar pattern needs to be performed if you want to use nullables instead of options. So I'm going to go right at the top, and instead of raise none or option raise, I'm going to use a context called nullable raise. So nullable raise, and find job by ID, I'm going to call this nullable, job ID. I'm going to override it below, so I'm going to have my override nullable raise. And the expression that I'm going to use there is very similar to that of the options. Instead of the raise, I'm going to use raise with the null value on the JVM. So it's the same kind of pattern. And if you want to convert your regular value in the context of a raise of your typed error to a nullable thing, so I'm going to have my fun, let's call this salary nullable, with job ID, and this is going to be a salary question mark. Then I'm going to have my nullable. I'm going to have jobs find job ID nullable, job ID dot salary, and that's going to be it. Now, if you want to convert backwards from option salary or salary question mark to a regular value in the context of raise, you can do that as follows. So for example, if you want to convert an option salary to a regular salary in the context of option raise, you can have context, option raise, function salary O, let's say, job ID. This returns a regular salary, so nothing optional there. And you're going to have salary with job ID, and then bind. So in the context of option raise, you have access to the bind extension method on the option of your type. And likewise for the nullable raise, so I'm going to have, let's say, context nullable raise fun salary n with job ID. This returns a salary without a question mark, and then you have salary nullable with job ID and then called bind. The pattern is exactly the same. Notice in these cases, both for options and for nullables, that the context that you have access to is either option raise or nullable raise. You never get the raise of job error, your typed errors back, because options and nullables essentially lose error type information. And likewise, there's an equivalent builder and bind function for result of type A, and the error type is throwable in this case, but the pattern is almost identical. Okay, let's move on to the big item number 2, which is how to combine raise values and errors. Let's build an example of how we would combine multiple values in the context of raise. So for example, here in the jobs interface, I'm going to create a context function. So context raise job error. I'm going to have a function, let's call this find all, which returns a list of job. Let me override that. So I'm going to have my override context job raise job error, find all, and so on and so forth. I am going to run a catch. So I'm going to say catch, and let me write some proper Kotlin here. So catch, and I'm going to have my jobs database values to list, and I'm going to catch any throwables. So I'm going to have underscore throwable. I'm going to say raise, and I'm going to raise one of the generic errors. So generic error with an error occurred while fetching all jobs. So something like that, and I might include the error inside if I want. Okay, cool. So in this case, we have a find all function in the context of a raise job error. Now, let me create another function, and I'm going to define it outside both classes. I'm going to define a max salary function as an extension function. So I'm going to have a context raise job error. And in the context of raise job error, I'm going to define extension function. So function list job max salary. And this returns the salary with an S, a capital S. And I'm going to say if is empty, I'm going to raise a generic error with, let's say, no jobs to compare. Let me add some parentheses here so that the compiler doesn't yell at me. And otherwise, I am going to say this max by, and its salary value is going to be my comparison function, and then salary because this max by returns a single job. Okay, so I have an extension function on list job. So we have two components here, one that says find all, one that says max salary. And let's also create another one that creates or returns the gap between max salary versus a certain job ID. So my job service at the bottom of the class, I'm going to have a context raise job error. And I'm going to have a function get salary gap versus max with a job ID, and this returns a double. And this returns the gap between the salary of this particular job ID versus the max salary in all the lists in the jobs database. So I'm going to have something along these lines. So val job, and I'm going to say jobs find by ID, job ID. This computation is in the context of raise. Then I'm going to have my job list as jobs find all. Again, this is in the context of raise. Then I'm going to have my max salary, which is a salary, as job list max salary. So notice that I can use extension functions in the context of arrays, and that is simply possible because the context of arrays applies to this whole scope. And then I'm going to return max return max salary value minus job salary value. So it is as straightforward as that. In the same context, you can combine or you can simply use regular Kotlin code as long as all the functions that you're using use the same raise context, or at least an included one. And obviously, if you want to use this get salary gap versus max in main, you'll have to use one of the functions that consume a raise context, like fold or catch or recover. Now, one problem that arises is what happens if one of the functions here is in another raise context. So, for example, if I want to convert the value of the difference here in euros, which raises a different kind of error like negative salary, I need to make some modifications. So in my job service, I'm going to have a currency converter as a currency converter, and I'm actually going to call this converter, and I'm going to use the raise one, so the raise currency converter. And I'm going to return converter dot, and I think I have to make that a val. So private val again, converter, and I'm going to have my convert USD to euros, and then I'm going to pass this value here. Now, this thing works because the convert USD to euros has the same raise context. Let's change it a little bit, and I'm going to go to my error domain model, and this negative salary I'm going to place in a different hierarchy. So sealed interface, I'm going to call this currency conversion error, and this currency conversion error is the type of my negative salary. And this currency conversion error now needs to be the context of my convert USD to euros. Now, notice that in this case, the convert USD to euros cannot be called in simply the context of raise job error because this convert USD to euros function is in a different context, which has nothing to do with the previous one. Now, if I want to be able to use this function, I have two options. Either I specify the raise currency conversion error here, which satisfies the compiler, but then I have to treat that here in my main function. And the error type that we would need to use here is the union type of the types in our arrays context. So let me give an example of how that would work. So I'm going to have my job service as job service with jobs and converter. And let's say that I want to say job service dot get salary gap versus max with job ID number 1. So this is my function here. Notice that in this case, job error is insufficient because get salary gap versus max needs to use both job error and currency conversion error, and these two have nothing to do with each other, so the common type is any in this case. And the compiler is actually quite happy to infer that to any, so notice that we have any here, and that may be a little more problematic for us when we want to treat it later when we do pattern matching. It may or may not, depending on what your code looks like. So that's version number 1, to use two contexts here. Or if you simply want to keep the same type error that you want to stick to, there is a way to convert the error raised by this structure into the error type that you want to stick to. So there is a construct called with error that will take a lambda from the error that you don't want into the error that you do want. So in our case, we need a lambda. We need a lambda that will take the currency conversion error into a job error. So this is the kind of structure that we need to throw here or raise. And in this case, I'm going to raise a generic error with, let's say, negative conversion amount. And as long as you provide this conversion function that returns an error that you want to stick to, then all is well, and you can stick to the raise job error context. So now we can run this program and see how this thing works. So we're calling get salary gap versus max. We have job error, and this is the salary difference now, salary difference in euros. And for our situation, we have job ID number 1 has 70K and the max is 90K. So the difference is 20K in US dollars. So in euros, that would be 18,000 something. So that would be, let's see. All right, 18,200 euros in salary difference. All right, and if we have job ID 11 or something like that, then we have a job not found, and the job error should be reported by this print line. Let's see. All right, so job error found, job not found, job ID, job ID. Okay, cool, awesome. Now, one last thing that I want to show you is how you can combine multiple errors into one. So I'm going to show you how we can surface out multiple errors for a single function call. So I'm going to have a context, and I'm going to have a raise, and I'm going to wrap this job error into a list, and specifically a non-empty list. Non-empty list that I'm going to import with job errors. Okay, now I'm going to have a function, let's say get salary gaps, plural versus max. We have IDs as a list of job ID, and this is going to give us back a list of double. And the function that I'm going to call that is map or accumulate. And you can pass an iterable, which in our case is the IDs, and then the mapping function, which can throw, quote unquote, throw a job error. So in this case, I'm going to call get salary gap versus max singular on it, and which is the argument to this lambda. And the it belongs to the IDs list. So what this construct does is it calls get salary gap versus max on every element in this list. And if every computation is quote unquote successful, then the list of doubles will be returned. If any one of the computations fails, it will be stored, that failure will be stored in a non-empty list with the job error, and all failed computations will be stored here in the non-empty list. So for example, I'm going to say job service get salary gaps versus max, so plural, and I'm going to have a list. So I'm going to say list of job ID 11 and job ID 2. So one of them is good and one of them is not. And we have errors here. We have print line job errors found errors. And we have salaries, which are gaps here, gaps, which is a list double. And we have salary differences in euros, salaries, or gaps, the way that I named them. So we have a failed one and a good one. Now, in this case, the computation will fail, and the failure will simply store one error because we only have one failed computation. So let's compile this. And we have job errors found, non-empty list, job not found with value 11. If we have 11 and 22, these errors will be stored in the same non-empty list. So job errors found, in this case, we have 2 errors accumulated in one final value. So notice that we can use map or accumulate to combine potentially errored computations. There's also a nice function called zip or accumulate, which can combine errors of potentially different types into one final value, and there are a lot of overloads for zip or accumulate. All right, so you can use map or accumulate or zip or accumulate if you want to combine multiple potentially failed computations in the same Raise context. So there you have it, folks, another long-form video on another way to handle errors idiomatically in Kotlin. I hope you liked this video and found it valuable. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check out the blog version because it has detailed explanations of everything that we discussed in this video. And check out my Rock the JVM website. It has hundreds of hours literally on everything that you may want in Scala, Kotlin, and so much more. Until next time, folks, this is Daniel signing off.